Welcome. We're very happy to have you. We are just getting started. I'm just going to give a brief introduction to the topic and the speakers, and then I will turn it over to Leah and Jessica. We wanted to have this webinar on 3-person IVF because it's a new technique used with IVF that many folks don't know about. And I know some folks in this call are very familiar, and for some folks it might be the first time that you're hearing about it, or maybe hearing about the specifics of how it works and background and implications. Also, we wanted to have this topic because it brings the ART field into the realm of altering genes that get passed down to future generations. And that's a topic we would really like this group to understand more about. It's an entirely new area that, if allowed, will affect women and reproduction, as well as many communities and the whole human species. So it's an important issue for us to know about and engage with, and we really like to have more conversations about it with the ART working group. So in terms of our speakers, Leah Lowthorp has a PhD in cultural anthropology and folklore from the University of Pennsylvania, and she came to CGS from a teaching appointment at Harvard. She's currently an American Council of Learned Societies Public Fellow and Program Manager at CGS, where she focuses on developments in 3-person IVF, international policy, and legislation concerning human germline modification, and applying storytelling approaches to CGS messaging and fundraising. Jessica Cussins is a 2017 Master's in Public Policy candidate at the Harvard Kennedy School, studying international science and technology policy, and currently completing her thesis with the NIH on the Precision Medicine Initiative. She's a student fellow in the biosecurity and cybersecurity programs at the Belfer Center, the chair of the Future Society, a research assistant for Harvard's program on science, technology, and society, and a consultant with CGS. She's passionate about the intersection of health, technology, and policy, and enjoys blogging about the ethics and politics of emerging technologies. So I'm going to turn it over to Leah, who's going to start us off with the background.
So 3-person IVF encompasses a range of related techniques that can create an embryo with genetic material from 3 different people: nuclear DNA from the intended parents and mitochondrial DNA from an egg provider. Many scientists consider the experimental techniques to be unsafe, with unknown and unforeseeable health consequences for the child as well as future generations. Mitochondria are the powerhouses of cells and are fundamental to proper cell function. When they are not functioning properly, as in the case, for example, of mitochondrial disease, this has system-wide implications such as organ damage and even death. The mitochondria contain DNA in the form of 37 genes that are known to determine certain disease inheritance, as well as play a role in metabolism, obesity, and lifespan, but are not currently known to code for any recognizable traits, as does nuclear DNA. However, mitochondrial DNA is still yet not fully understood, so we don't quite know all of what it does. So mitochondrial DNA is only inherited through the mother, so 3-person IVF results in germline modification, or changes to eggs, sperm, or embryos that would be passed on to future generations, only in cases where female-sex babies are born that could then pass on their DNA to future generations. These techniques have been referred to in a number of ways, including the term we've been using, 3-person IVF, or 3P-IVF for short, mitochondrial replacement, mitochondrial donation, mitochondrial manipulation, mitochondrial transfer, 3-parent babies, which is the favorite of the media, and the most technically accurate term, nuclear genome transfer. Now, most of these terms are actually misnomers, as they imply that it is the mitochondria that are being transferred to a new cell, when in fact, it is actually the nucleus that is transferred. And the fact that 3-person IVF is a biologically extreme procedure has been widely downplayed through this mitochondrial transfer imagery, with many claiming it is simply changing a cell's batteries. There are 2 main techniques, both of which transfer the nucleus of one egg to another resulting in a hybrid egg or embryo with nuclear DNA and mitochondrial DNA from different individuals. These are essentially the same technique, differing only in the timing of fertilization. So the first, which is called maternal spindle transfer, or MST, is where a donor egg's nucleus is removed and replaced with the nucleus of the intending mother and afterwards fertilized. And the second technique, called pronuclear transfer, or PNT, is where both eggs are first fertilized and then the nucleus of the intending mother replaces the donor egg's nucleus, with the donor egg's nucleus simply discarded. So why is this done? The stated goal of 3-person IVF is to allow a small number of individuals with severe mitochondrial disease to have a healthy and mostly genetically related child. Mitochondrial disease is known to affect about 1 in 5 to 10,000 people. However, these techniques would only help about 15% of cases, because most are actually caused by problems in nuclear rather than mitochondrial DNA. And out of this 15% of cases, most could be helped using PGD. So this would in effect only help a very small number of people have genetically related children. And of course, they could also have healthy children using donor eggs or adoption. Many frame this technique as saving lives by quote-unquote healing mitochondrial disease, but a 2016 Institute of Medicine report states that the technique, quote, does not address a medical need because it would not treat an existing person for a disease, illness, or condition. So while mitochondrial disease is the most widely stated aim of 3-person IVF at the moment, we know that its application in non-disease related fertility treatments has been part of the story from the start, a point I will return to later. And just to briefly summarize major concerns, so critical questions about the safety and efficacy of these techniques have not yet been answered, and they raise profoundly important social and ethical questions. And this could open the door to wide-scale embryogenetic engineering for reproduction. I'll pass it on to Jessica.
Thanks, Leah.
Thank you, and hi, everyone. I want to also thank Marcy and Emily and everyone at CGS for inviting me to speak today. It's great to see so many familiar faces. As many of you know, I worked as a project associate at CGS for 3 years before coming to grad school. And I followed the developments in 3-person IVF for a lot of that time. So I'm really excited to talk about it with you all. A quick roadmap for my talk today. First, I'll explain a little bit about how and why CGS first became interested in 3-person IVF, then talk about the policy developments that we've seen in the UK and the US. And then I'll talk about some of the broader context and ethical considerations. So we first started hearing about these techniques back in 2012. At that time, a small number of scientists in New York and Oregon in the US, as well as in Newcastle in the UK, started putting out papers describing their efforts. I think it's safe to say that nobody really knew what to make of them at that time. People weren't sure if it was like IVF or like cloning, or whether it resulted in germline modification that would permanently alter the human gene. Some of the papers acknowledged that this was the same technique used for somatic cell nuclear transfer, otherwise known as cloning. Some acknowledged that this would create permanent changes to the genome of any resulting children and their descendants. CGS was really one of the few organizations that caught on at this early stage and started reporting on the fact that 3-person IVF did in fact constitute inheritable human genetic modification, and that it therefore was not just a minimal or additional technique added on to the IVF process, but was actually biologically unprecedented and part of a much larger conversation about the extent of experimentation and control that would be ethically acceptable to exert on a future person. CGS helped to position 3-person IVF in the international policy landscape and suggested that the dominant frames being used were largely wrong. So there were many common misperceptions that started circulating in 2013. These included the notion that this was a treatment that would save lives. Leah talked about this a little bit. Also that it would eliminate disease, that it was the only option available to women who wanted a healthy child, that it would help many people, that the techniques were proven to work in animals, that there was broad public support, that the biological contribution of the mitochondrial DNA is inconsequential, and that the slippery slope argument was overstated. In fact, I think none of these things turned out to be true. Only a small percentage of women with mitochondrial disorders are eligible for the use of this technique, and it can actually be pretty dangerous for those women to carry a pregnancy. Moreover, advances in the genetic sequencing of embryos were already showing promise for the prevention of mitochondrial diseases in a significantly safer way. All of which is to say that the medical rationale for three-person IVF was always pretty flimsy. A common metaphor that was used was that mitochondrial replacement was like changing a battery. The image this metaphor creates is that what matters about the entity itself isn't altered, which fits with the notion that mitochondria merely provide a cell's energy. However, a lot of research started coming out that suggested that mitochondria actually play a key role in determining many of our traits. This led to an editorial in New Scientist in September 2014, where they admitted that three-person IVF was much more challenging ethically than they had previously realized, because a resulting child would genuinely inherit traits from three people. The UK is the only country to date that has an explicit legal exception to allow three-person IVF, and the policy process that led to this was pretty fascinating. It did have a number of commendable aspects to it. The UK has a regulatory agency that deals with assisted reproductive technologies. This is called the Human Fertilization and Embryology Authority, or the HFEA. So this already distinguishes it from the US, which, as you know, has no explicit regulation of the fertility industry. The HFEA had multiple scientific reviews and also conducted a public consultation. On the face of it, this was a measured, thoughtful approach, and many people have congratulated the UK for its well-respected regulatory regime. However, what I found while I was at CGS and able to dig deeper into the reports and the meetings was that actually there were many warning signs along the way that were simply ignored. Scientists from around the world who worked on similar techniques wrote to the HFEA on multiple occasions to explain why they thought these methods were too dangerous to ever be ethical. Additionally, the HFEA originally required the Newcastle researchers to try out their method in macaques to prove that it might work in humans. Buried deep within one of their science reviews, it was explained that these experiments in the macaques did not work. Instead of shifting gears and trying to figure out why, the HFEA just dropped the requirement for the primate model altogether. Finally, in the public consultation that was carried out by the HFEA, it was widely reported that they found broad public support. However, in the only part of their consultation that was open to the public, the majority of respondents said they did not support the techniques. In many of the meetings I watched, the public dissent was completely overlooked and dismissed as being either religious or theoretical. But I would suggest that it was actually something close to blind faith in technological progress that was pushing forward this agenda all along. I wasn't the only one who noticed this. The scientist Ted Morrow, who was at one of the scientific meetings led by the UK Parliament's Science and Technology Committee in October 2014, tweeted after the fact asking, "What's the point of funding, performing, publishing, and requesting scientific evidence if it's then ignored?" Nonetheless, in February 2015, the UK did write into law an exception to its prohibition on human germline modification in order to enable three-person IVF for the purpose of prevention of mitochondrial disease. Amazingly, the Newcastle researchers who had pushed for this law to be changed did not publish their scientific paper until more than a year after the law was changed. And what they reported was that their technique did not work. Instead, they said they were trying a new version called early PNT or EPNT, which they said might reduce the risk, but still could not guarantee prevention. Just last week, the HFEA granted a license to Newcastle to start using the technique on qualifying women. Of course, this comes after reports of births have already come from other countries that do not have any regulations on the matter, but Leah will talk more about that later. I think it's important to remember these stories from the UK policy process because this will always be the first example of legalization of genetic engineering of human embryos for the purpose of reproduction. It will be looked to as a model for how to enable additional experiments. But in my opinion, the willingness to listen and adapt was mostly an appearance. As we face policy changes for many more kinds of human genetic engineering, we should remember that in this case, finding out the technique did not work as intended and finding out that many people opposed it was not enough even to slow it down. In the US, the policy framework has looked quite different. In early 2014, the FDA held a public meeting to discuss the scientific and technological issues related with three-person IVF. What was most striking about this meeting was how many unknowns were raised. Not one member of the public spoke in favor of the techniques. A woman who had mitochondrial disease herself spoke about her wish for attention to help the women who actually have these diseases, instead of encouraging them to have children they may struggle to care for. The chair of the committee concluded the meeting by saying that more animal studies of larger sizes would be critical before moving forward. He also acknowledged that many of the concerns were not about safety and efficacy, but actually about ethics, and that it was not within the purview of the FDA to address these issues. Following this realization, the FDA requested the Institute of Medicine to conduct a series of subsequent meetings to consider the ethical and social policy issues raised by what they termed genetic modification of eggs and zygotes to prevent transmission of mitochondrial disease. They came up with some different notions from the UK, including that only boys should be allowed to be born, which was their attempt to prevent the intergenerational risk, since the mitochondria are passed along the maternal line. Clinical use of these techniques is not currently moving ahead in the US, partly due to a rider in a congressional spending bill that prohibits federal funding of genetic engineering of embryos. Moreover, the FDA would require any fertility specialists seeking to use this to apply for an investigational new drug license. Importantly, in the US, the FDA cannot regulate off-label uses, which is worth remembering given that one of the primary US scientists wants to use this for infertility instead of for disease prevention. So now that I've talked a bit about the policy processes in the UK and the US, I want to step back for a minute to think about the broader context and the ethical questions that are at stake. I have 6 buckets of ethical issues here that one might think about. The first 2 are about safety. Number 1 is really about the safety for any resulting children. It has been suggested that this might be so profound as to point to the limits of human biological experimentation, and really questioning what is an acceptable level of risk here, given that this isn't about saving a life, but about creating one. The second bucket is about safety for the women involved, and this includes both the women who are providing their eggs as well as those carrying out the pregnancies. The third point is about the notion of informed consent. This is obviously completely overridden for the person that would be affected, since they wouldn't exist yet. But it's also extremely hard for the parents making these decisions, given that actually even the scientists themselves don't know how this will work out. The fourth bucket is about the exertion of control over another human's body and life. And the questions here are, what are the limits there that are acceptable? Obviously, we have some kind of control over our children on a regular basis, but does this push against some limit there? And who decides that? Also, should we think of the germline as a kind of human commons? The fifth bucket is about identity concerns. Will the people who are born from these techniques think of themselves differently for having 3 genetic parents? In the UK, in the regulation, they've said that the children are actually never allowed to know the identity of their donor. And the sixth final bucket is around issues of discrimination and equality. So whose values decide what is an acceptable life to bring into this world? Will this result in less care for people that don't fit that mold today? And will it lead to greater inequality between those with means to access these technologies and those without? So I would argue that none of these concerns are easy to overcome, but also that I think these issues are raised both by 3-person IVF and by CRISPR gene editing. 3-person IVF can also be used for non-disease purposes, as we've already seen in Ukraine where it was used for infertility. And it has also been suggested that it could hypothetically improve athleticism or even intelligence in future offspring. For a number of reasons, most people treat 3-person IVF as being less consequential, both technically and ethically, than gene editing, and I'm not sure that this is warranted. Now that the UK allows a technique that alters 37 genes in a resulting person, I'm not sure why they will prevent future techniques that only seek to alter a single gene. So that's the end of my presentation, but I look forward to your questions at the end of the hour. Thank you.
Thanks, Jessica, so much. That was a really great overview of so many of the issues, and we're going to go back to Leah now.
Right, so I've been at CGS since September, and since I've arrived, there have been a number of major breaking news stories in the arena of 3-person IVF, particularly the first ever live births, the first in September in Mexico to avoid mitochondrial disease, and the second in early October in Ukraine to treat infertility. A few weeks later, rumors of another one in China, and another child is expected in Ukraine anytime now. They said sometime in March. So the first case, on September 27th, it was reported that a baby created using 3-person IVF had been born 5 months earlier to a Jordanian couple who had previously lost 2 children to mitochondrial disease. The procedure was conducted by Dr. John Zhang, a New York-based fertility doctor, who openly admitted that he did the work in Mexico in order to evade the US regulatory process. The case went largely uncriticized by the scientific community, although it raised serious concerns among some scientists, such as Zhang's dangerous flouting of regulations, making this an unethical living human experiment, the shoddy nature of the work itself, its promotion of medical tourism, and the unknown long-term effects of the technique on the child born. As a consolation prize, at least the fact that the baby was a boy meant that these changes would not be heritable. The media craze that followed largely heroized Zhang, depicting him as a doctor altruistically seeking to prevent the transmission of mitochondrial disease, widely quoting him as saying, quote, "To save lives is the ethical thing to do," as well as downplaying the serious risks involved for the baby and future generations. So despite Zhang's focus on his own heroism, and the general wider focus placed on only using 3-PIVF in cases of severe mitochondrial disease, only 8 months earlier, Zhang himself had posted a video in which he lauded the usefulness of 3-PIVF as a fertility treatment. So moving on, less than 2 weeks after the story of the Mexico birth broke, a second story broke, this time in Ukraine. Valerie Zukin, a fertility doctor in Kiev, had used 3-person IVF as a treatment for general infertility for 2 women, then pregnant in their 3rd trimesters. He used the technique to apparently overcome the early stage embryo arrest that had affected both women during IVF. The media was surprisingly quiet given the storm just 12 days earlier, although the BBC did publish a somewhat critical piece entitled 3-Person Baby Race Dangerous. The first baby was a girl, meaning that these changes will be heritable, and she was born in January, and the second, as I mentioned, is due any time now. So Zhang surprisingly came out as a critic of Zukin, particularly of his outdated methodology. He used a virus protein to fuse the nucleus with the host egg, meaning that the viral DNA would actually be permanently integrated into the future child's DNA. And this is the main fact that Zhang critiqued, because he himself used a newer electronic system that would leave no traces, and said that people don't even use viral vectors anymore in animal research. So this is an interesting point that I didn't see mentioned anywhere else. He also critiqued the fact that the patient was 34 years old, and he was saying that according to statistics, she would have eventually gotten pregnant anyway, so there's really no reason to use this technique to treat her in this case. So a week later, news broke of a live birth in China using some kind of 3-PIVF technique, but with no specific details, and the research report is said to be under review. So despite the singular focus within larger 3-person IVF policy conversations, as we saw with Jessica's talk, on saving lives and healing mitochondrial disease, its potential use for infertility has been part of the story from the very start. Its precursor technique, called cytoplasmic transfer, was developed in the early 1990s to treat age-related infertility. The idea behind the technique was to infuse aging eggs with malfunctioning mitochondria with healthy mitochondria from young eggs to provide an extra boost of energy that would aid in embryo development. This was done by sucking out the mitochondria-rich cytoplasm, or jelly-like semi-fluid surrounding the nucleus, from a donor egg and injecting it into the recipient egg. Never tested in clinical trials, from the 1990s to early 2000s, 30 to 50 children were born worldwide using the technique. The FDA halted the procedure in 2001, citing lack of evidence of safety and efficacy, and requiring clinics to seek the agency's approval to continue, which none ever did, as far as I know. So the first ever follow-up study of 17 children born in the US in the early 2000s as a result of this technique was coincidentally published just a week after we heard about the Ukraine case, and only 1 month approximately after the Mexico birth. The study itself openly admitted its limited subjective nature, but concluded that all of the children they were able to get information about, which was reported by the parents, not by the children themselves, as many of them had not been told that they were created using this technique. So all of the children they were able to get information about were ostensibly healthy. And the media itself, upon hearing this, went wild, claiming that this proved that 3P IVF was safe. And a week after this, the editor of the journal in which the study was published came out with a scathing critique of what he called the shoddy scientific journalism surrounding the study, asserting that the two techniques are so different from one another, the study doesn't prove anything about the current or future safety of experimental 3-person IVF techniques. And 1 week after this, we see this interesting week-by-week chronology over about a 6-week period. The well-known 3-person IVF researcher Mitochondrial, who is based in Oregon, published a paper proposing the introduction of 3-person IVF technology as a fertility treatment, focusing on a different technique called polar body transfer, which he characterized as, quote, just one additional advance over IVF, end quote. The new study promised a 2-for-1 deal for aging women to, quote, increase the yield available for transfer from a single stimulation cycle, end quote. So this centers around the fact that during the process of egg maturation, something called the polar body, which contains a full set of nuclear DNA, breaks off and is generally reabsorbed back into the body. So in this paper, Mitochondrial was proposing that a woman go through IVF, 1, with her own egg, and 2, at the same time go through 3P IVF by transferring the nucleus of her polar body into a donor egg. So essentially creating a 2-for-1 deal for 1 single egg maturation process. So I imagine he'll be pushing this in the future. So coming to the major concerns, it's important to stress that all of these techniques are still experimental. Nothing has been proven. The fact that Zoo can use this to treat infertility in Ukraine doesn't mean, that it actually does per se. Perhaps these were 2 cases that happened to work at the same time that he was doing this procedure. We don't know. There have been no trials. And so the safety concerns, many of which Jessica mentioned. So this is a biologically extreme procedure that has never before been done in the history of human evolution. So mitochondrial DNA and nuclear DNA have co-evolved over time, and we don't actually know the consequences of a mismatch between the 2 of them. Studies have also come out showing that mitochondria have a differential replication rate. So that when you actually take the nucleus of the intended mother out of the cell to put in the donor egg, it's impossible to avoid taking along with it some of her original mitochondria. So in the case of mitochondrial disease, quote unquote, diseased mitochondria with it. And if her original mitochondria replicate faster than the donor egg's mitochondria, they can eventually take over the donor egg. So over time, the child born, or as the embryo develops, it can actually revert back to the original mitochondrial disease. And for the use of disease prevention, as I mentioned, this will also only help a very small number of people, as only a small percentage of mitochondrial disease is caused by faulty mitochondrial DNA itself, and PGD is possible in most of these cases. So this represents a huge amount of resources, both financial and in research, to help a very small number of individuals have genetically related children. And again, this does not treat an existing person for a disease, illness, or condition. And and individuals themselves actually living with mitochondrial disease, many of them have said they prefer this amount of resources and funding to be used to actually treat those living with the disease than to help hypothetical future people. So to conclude, why the push for 3P IVF and why the dedication of a huge amount of resources to it? We think that it's because of the potential prize of the fertility industry as a fertility clinic add-on. And so some of the risks involved here would be exploiting vulnerable families that have had multiple failed cycles and convincing them to put the health of their future children at risk, creating a demand for more eggs and the safety issues involved in that. Of course, cross-border fertility market issues that we've already seen going on. This could also potentially generate interest among the LGBTQIA+ community for a technique that seems to provide a biological alternative to traditional family formation. Although, as Jessica said, this would be currently unfeasible in the UK because of the required anonymity of donors. And finally, the disturbing potential for Matalipov's 2-for-1 deal that the developing polar body transfer method could possibly be marketed to IVF users in the future. Thank you.
All right. Well, I really want to thank Jessica and Leah so much for all the work you've done on this issue just overall that allowed you to, comment as you did and the way you put together your remarks, and I think really helpful to folks. And we will keep everyone posted on our next webinar for the year. Probably have 2 or 3 more. And if you have ideas of something you'd like to see covered or speakers you'd like to invite, please let me know. We're definitely open to suggestions from the group. And I hope that everybody has a great day. Thank you for joining us today.